Physical Science. This is Chemistry 2.1. Here are all the things we're doing today. These are the elements that you need to know, your physical states marked on your new periodic table, the different types of notation, the flashcards that you're making, and the assignment that you need to complete with them. You're going to find the number of protons, neutrons, electrons, and finally, do some practice. So the elements that you need to know 52 separate elements. They're listed on the periodic table with 4 pieces of information. They're elements 1 through 30, 33 through 36, 38 through 40, 47 through 50, 53 through 56, 74, 78 through 80, 82 and 83, and 86. Part of your assignment today is going to be doing the complete notation on as many flashcards as you can get done. On your periodic table right now, you need to identify some physical states of matter. Remember, the physical states of matter from Unit 1 are solid, liquid, and gas. Well, the overwhelming majority of your periodic table is solid. There are 2 elements that are found in liquid state, bromine and mercury, element 35 and 80. Mark those with kind of a wavy line and put a little wavy line in front of liquid on your periodic table. Then you have several elements that are actually gas at room temperature. Those are hydrogen, nitrogen, oxygen, fluorine, and chlorine, and all of the last column, that is elements 2, 10, 18, 36, 54, and 86. You need to circle the symbol so that you know that it's a gas and put a circle in the gas box on your periodic table. The periodic table notation. Periodic table notation looks like this. The top number is the atomic number. The letter combination is the symbol, the word is the name, and the bottom number is the average atomic mass, abbreviated AAM. Complete notation looks like this. There will be no charge in complete notation, but the top left number is the atomic mass, the bottom left number is the atomic number. To get the atomic mass, you take the average atomic mass and round it to the nearest whole number. Eventually, in 2.4, there will be a charge that will be added to your cards as well, and that will go on the top right. And obviously, the letter combination is the symbol. This is known as complete notation, and you do need to update your cards with their atomic mass and atomic number. Again, to find the atomic mass, you take the average atomic mass listed on the periodic table, round it to the nearest whole number, and that will be the atomic mass. Hyphen notation looks like this. It is simply the symbol and its atomic mass. Again, to find the atomic mass, you take the average atomic mass from the periodic table and round to the nearest whole number. So how to make your flashcards? Well, you've already started making your flashcards, and on the front of your flashcards, you have the symbol and the name on the back. Now you need to add the complete notation. You need to add the atomic number, which is the top right number. The top number of the periodic table becomes the bottom left number on your flashcard. And then the symbol becomes the symbol. And the bottom number on the periodic table notation, that is the average atomic mass, gets rounded to the nearest whole number, and it goes on the top left. The placement of these on your flashcards is incredibly important, so be sure that you do them correctly, do them slowly. You don't have to turn them all in next time. Let's talk about the subatomic particles. You are going to encounter 3 subatomic particles. You need to know their charge, mass, and location. Your subatomic particles are protons, neutrons, and electrons. Protons have a positive charge, are located in the nucleus, and have a mass of 1. Neutrons have no charge, are located in the nucleus, and also have a mass of 1. And electrons have a negative charge, are located in orbit around the nucleus, and for all intents and purposes have a mass of 0. They don't actually have a mass of 0, but compared to the mass of a proton and neutron, they have a mass that is negligible, so we call it 0. The atomic number is equal to the number of protons and the number of electrons if there's no charge, and nothing you do right now is going to have a charge. So the atomic number is equal to the number of protons and the number of electrons. The atomic mass is equal to the number of protons plus the number of neutrons. The atomic mass is equal to the atomic number, which is the number of protons, plus the number of neutrons. So how do you find the number of protons? Well, if you're looking at periodic table notation, it will be the atomic number. It will be that beautiful top number. If you're looking at complete notation, it will be the bottom left number. And if you're looking at hyphen notation, you will actually have to go to the periodic table, find the symbol, and look it up. In this case, silicon has an atomic number of 14, therefore it has 14 protons. The number of neutrons is the atomic mass minus the atomic number. Remember, to get the atomic mass, it is the rounded average atomic mass. So in periodic table notation, hydrogen has 0 neutrons because it is 1.01 rounded to the nearest whole number, minus 1 to be 0. The number of neutrons again in complete notation will be 34 for bromine because it will be the 79 minus 35, the atomic mass minus the atomic number. For silicon, you remember you have to look that up. So that would be 28 because you're given in hyphen notation the atomic mass, 28, minus the atomic number of 14 to get 14 neutrons. The number of electrons, remember, is equal to the number of protons. So in periodic table notation, it will be the top number. In complete notation, it will be the bottom number because it equals the number of protons. So let's look at some practice. Here's what you have to do on your assignment today. I'm going to give you a list of elements. You're going to write them in complete notation, hyphen notation, and identify their name, protons, neutrons, and electrons. So this name is easy. It's magnesium straight off the periodic table. There are 12 protons because it's the top number. There are 12 neutrons because 24.31 rounds to be 24 minus 12 is 12. And there are 12 electrons because it's the same as the protons. In this one, this is phosphorus in complete notation. 15 protons because it's the bottom left number, 15 neutrons because 30 minus 15 is 15, and there are 15 electrons because it equals the number of protons. You'll be doing lots of problems in class. Thanks for watching.